next session on ANSYS Workbench tutorials. In this session, we are going to analyze the Shackle pin for its modal analysis. We will start by double-clicking on Modal module. We'll first go to Engineering Data, Engineering Data Sources, General Materials. I'm going to choose stainless steel as a material. I'll go to Project and Update Project. You can also use alloy steel as the material. I have already analyzed the T-shackle using alloy steel. So you can take up those properties and analyze the pin as well. Next I'll go to geometry, right click and import the geometry of the T-shackle. Next I'll go to model and double click on it. I'll first go to geometry and choose the shackle pin. Allocate the material stainless steel. Also to the shackle, I will allocate the material stainless steel. Next I'll go to mesh. I'll change the sizing to fine and update. Now I'm going to compress the shackle pin for some time so that I can allocate the boundary conditions on the shackle. I'll go to model and I'll right click and insert fixed support. I'll choose these ends and click on apply. Next I'll go to the shackle pin and unsuppress the body once again. Then I'll go to solution and solve. You can see here these are the 6 modes. When you go to analysis settings, you can see the max modes to find is 6. You can either keep it to 6 or you can increase this to any number that you want. Suppose if I have chosen 10, I'll just go to solution and solve once again. You can see here these 10 lines have appeared for the 10 modes and already the frequencies have got calculated. So I'll click here and select all. Then I'll right click and create mode shape results such that I can obtain the deformations for each of them. But I do not want the deformation for the entire body. As you can see, all the bodies have been selected. I only want to see for the pin. So I will just go to deformation and make a small change here that I want to see for the pin only. Now I'll go to solution and solve once again. So you can see all the solutions have been obtained. When you go to the first, the total deformation, you will see the value of frequency is 2756.9 Hz. The maximum deformation is 0.652 mm. Minimum value is really very small. You can click on animation and you can see the first mode of frequency. I'll go to edges option and click on no wireframe so that I can see the animation clearly. If you want, you can also click on max min to find out where the deformation is maximum and where it is minimum. Now I'll go for the deformation 2. I'll animate and check the result. You can just turn the body and see the pattern of its motion. Here the frequency is 4560.4 Hz and the deformation is 2.9372 mm. That to the maximum value. Minimum value is actually so small that it is negligible. But you can focus on the maximum value as that can lead to some problem in working of the entire mechanism. When you go to deformation 3, the maximum value of deformation is 1.864 mm and the frequency is 7131.5 Hz. This value is really high and it really needs to be high so that your pin is safe. Otherwise, if this natural frequency is tapped easily, then your pin will easily show a deformation and it will go into resonance and create a problem in working. For deformation 4, you can animate and check the result. The maximum deformation is really high. It is 1082.4 mm and the frequency is 9133.2 Hz. Next we go for deformation 5. Here the value of deformation is 4.129 mm and the frequency is 15,518 Hz. For the sixth deformation, the frequency is 15,589 Hz and the maximum deformation is 9.42 mm. You can check its pattern of motion. Next we'll go for the seventh one. Here the maximum deformation is quite high, 825.42 mm and the frequency at which this occurs is 20,553 Hz. For the eighth one, you can see its pattern of motion. Maximum deformation is again very high, 1199 mm and the value of frequency is really high, 21,177 Hz. Generally, these high frequencies are not tapped and so the body would really remain safe at this high value of frequency. For the ninth one, the value of deformation is 18.14 mm. Again, the deformation has reduced. The value of frequency is 22,660 Hz and you can see its pattern of motion. And for the 10th one, that is the last one, you can check its pattern of motion. Value of deformation further reduces, it is 6.57 mm and the frequency has increased to 23,171 Hz. Generally, these high frequencies are not tapped so your body remains safe. And it should be that way so that your body doesn't attend this resonance because of a particular mechanism tapping into this body's natural frequency. So with this, I end the session. I hope you have understood how to analyze the de-shackle pin for its modal analysis using stainless steel as a material. What would be the result using alloy steel? I leave the solution to you to figure out. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.